2NURFM 103.7, Monday morning, and here we go. And great to welcome some of our regular guests actually back into the studio. And one of those joins us right now, Professor of Science from the University of Newcastle, John O'Connor. Mate, I'm sure the GPS still works, so you could remember how to find the place. Good morning.
It still works, yes. Almost automatic these days.
That's the main thing. As long as you got here and as long as you've brought with you, as you always do, a very interesting topic from the world of science. Now, plastic is one of those substances that's always maligned. We're always looking for a new way to do things in that space. There is a new substance that really will give what we know as plastic a bit of an upgrade.
Yes, I mean, when we think of plastic, we usually think of something relatively soft. Because it's and that comes about because of its structure. Whether it's a plastic or a polymer, they're like polymers, like taking small bits of molecule and stringing them together, and that's has some benefits, but it ends up a bit like a bowl of spaghetti, like all tangled and so forth, and that doesn't always make it particularly strong. What you want to do is get some order in there, and that's been the real challenge, is to get some order in. Now, some plastics are hard. I think this desk is probably covered with melamine, and that's fairly hard. And so what a group at MIT did was to take melamine, which is basically small molecules that they add together as in a polymer, but rather than let them just straggle around like a bunch of sheep or whatever, they managed to get them to lay out as a very thin disc. So they actually stick into these little furrows, and then on top of that another one, and on top of that another one. So they set up a whole series of layers of these atomically or molecularly thin layers, and between the layers they're connected by hydrogen bonds, which is still a strong bond. But the resultant is a material that has some rather special properties. It's only about 1/6 the density of steel, so it's a relatively light material, but it takes twice the force that you would apply to steel to deform it. So it's going to be a really strong material compared to steel, and very light.
So this is, to me, it's almost like the plastic version of you get a rope and you tie different ropes together, it becomes a lot stronger than it would normally be with just one.
That's right. And instead of doing it in the linear fashion there with a rope, you're actually doing it in a flat, the planar fashion. Now, this has an analogy in one of the strongest materials we know, which is graphene. Now, graphene is a series of single atomic layer carbon. Now, carbon you can think of as diamond, which is really hard, or you can think of it as graphite, which is really soft. But graphene, which comes from graphite, something really soft, if you strip out those individual layers, they're each really strong. And they also, because of this layering, if you can build up the layers and get a good bond between them, again, they can produce a really strong material. But this particular material, they're talking about using as a coating. Although I'm not quite sure why you make coating out of something so light and so strong. Maybe make the thing itself out of it.
Well, it's interesting when you look at substances, how they can be used for quite a wide and varied applications. Now, if we're looking at using this new substance, is your line of thinking, John, that in time this could actually be what we see and know as plastic? This substance could actually completely take over that space?
Well, if you look at a modern motor vehicle, a lot of the vehicle itself is now been replaced with plastic parts, and that's certainly reduced the weight of them. If this material now has the strength of steel and it's 1/6 the density, therefore for an equivalent component it would be 1/6 the weight, and that means even more of the motor vehicle could be made out of a lightweight material, and always that lightweight. You don't want to sacrifice strength because that is what protects you, but the weight is the thing that really chews up energy, whether it's petrol driven or electric driven or whatever. By reducing that weight, you actually save a lot of energy. So we may actually see this evolve into something which gets into more and more of our lives, whether it's motor vehicles, bicycles, who knows. But certainly it has that capacity, as long as they can get it from the laboratory into the industry, and that's always the big challenge. It's called the valley of death, going from the laboratory to a final product, because it's got to go through various stages to prove that it's commercially viable, that you can actually produce it in the quantities and the shapes you want.
Yeah, in theory, something works in a test tube. Not that this is in a test tube, but it works in that environment. And then, like you said, it's got to go through all those other practical and financial challenges to see who can actually hit the ground running.
That's right. And I think from memory, what is it? For every dollar spent on research, you need about $100 on the development and the marketing and so forth. So yeah, that's why it's a valley of death. You might have actually proven the product, but you've now got to get out in the big bad world.
You've got to get out and sell it.
Yes.
All right.
Make it attractive to the consumer.
We will see if this new type of plastic actually makes it through the valley of death and indeed into some wider applications. Our Professor of Science, John O'Connor from the University of Newcastle, mate, as always, appreciate your time. We'll talk to you next time.
Thanks, Mark.
Right here at 2NURFM 103.7.
A broadcast service of the University of Newcastle.